This video is all about trigonometric addition formula. Now we want to prove how these formulas comes about. Now before we start, I want to appreciate my subscribers and my new subscribers. I also want to appreciate my viewers. Please, my viewers, please subscribe, write your comments, like, and also share the video. Now let's begin. Let's begin. Now, okay, I want to change the color of the pen to white. I prefer white on a green um, board. So now let's begin. Let's now draw. It's a geometric proof. Now I will now draw a line. Now draw a vertical line. This line is the y-axis. I'll draw a horizontal line. This is the x-axis. Now I will draw another line radiating from this point. Now I'll call this I'll call this angle. This angle is A. This angle here is B. Now I'll call here C. This point C, D, E. Now at a point on CE, I will draw a line that is perpendicular to line CD. So there's is perpendicular here. Then I'll also draw a line parallel to Y but perpendicular to the x-axis. I'll also draw another line from here down that is also perpendicular, a parallel line perpendicular to the x-axis. A parallel line that is parallel to the y-axis but perpendicular to the x-axis. Now I will draw a line from here parallel to the x-axis, perpendicular to the y-axis, and also perpendicular to this line. Now this line is F, this is G, this is G. From here to here is this is I, J. Here is my K. Now having drawn this, here is A. Angle C G. Let me draw angle like this. Angle CGI, which is here, plus angle GCI, which is here, plus angle CIG. So let me be putting it on top of this place. There is no need using that one. So this also represents angle. So now this angle plus this angle plus this angle is equal to 180. That is the sum of angle of a triangle. Now, since we know we're looking for CGI plus the CGI, now the GCI, which is A, angle A, plus the CIG, which is this angle here, which is angle 90, is equal to 180. So now, having done this, we are looking for this angle. So this angle now, if you move this angle, this 90 to this other side, this angle A to this other side of the equation, you now have CGI equal to 180 minus 90 minus A. 180 minus 90 will give you 90 minus A. So the angle CGI is 90 minus A. So here is 90 minus A. So if here is 90 minus A, and you know this angle here, this line here, and this line, they are at 90 to each other. So here is 90. From here to here is 90. Now if it is 90, now I don't just want to, although if you look critically without even solving, you will see that this line is parallel to this line, and there is a line here joining both lines. Then then this angle here, which is A, is equal to this one. Well, we have to prove it so that some other people, know there are people that will look at it and say, okay, this supposed to be A and this like that. So, but we need to explain further so that some people that don't know, we have to know. Like if here, and since here is A, here will be A too, but we need to prove it so that some other people will follow. Now, having done that, I will now, here is A now. Let's put it there. So we have proved. Okay, we have not proved it, but let's prove it now. Since angle KGI is equal to 90 based on our diagram, 90 degree, and angle CGI is equal to 90 minus A, then angle KGC plus angle CGI is equal to angle KGI. And now this angle is what we're looking for, the KGC plus the CGI is 90 minus A. Now you have KGI is known, KGI is 90. Now, so to get your KGC, we now move, if we move this to this other side, it becomes positive. We move this to this other side, it becomes negative. It becomes negative. So we now have 90 plus A minus 90. So because this is plus 90, so if we move into this other side of the equation, of the cosine, it becomes minus. So now you now have KGI equal to 90 minus 90 will cancel out. You are left with A. So that means this is to show that this is A. Now, we also know that so here is also A, but let's prove it. You know that CGF is equal to 90 based on the diagram, based on our submissions, because we said drawing a line from here perpendicular to this line. So here is 90. So that means CGF is 90. Now if CGF is 90, and we know that KGC plus KGF is equal to CGF, and KGC is A plus KGF is equal to, this one is 90. CGF is 90. So if you move this A to this other side, you now have KGF equal to 90 minus A. Now, applying the the geometric law, where you say the sum of angle of a triangle is 90. It's not 90, it's 180. So now it means that angle KFG plus angle FKG plus angle KGF is equal to 180. It's equal to 180. So now that means we have K, we have F K G to be equal to 90 degrees. So angle KFG is equal to 90 degrees. So now if you substitute all this value into this equation, we now have angle KFG plus angle 90, because of FKG is 90, plus angle 90 minus A is equal to 180. So now if you now sum 90 plus 90, you have, now let's write it out now. You have KFG plus 180 minus A is equal to 180. Now let's go to the next page. You have KFG plus 180 minus A is equal to 180. So if you move minus A to this other side, it becomes plus. You move plus 180 to this other side, it becomes minus. You have KFG equal to 180 plus A minus 180. So this will cancel out this. You have KFG equal to A. So now, having gotten all this explained, so here is A, here is A. So now the next thing we're going to do, we have angle ECI to be A plus B. So let's look for sine A plus B. Sine A plus B will be equal to, looking at it now, we'll only consider a geometry that forms a triangle here. So this is only the geometry that forms a triangle, which is triangle CFJ. That is this triangle. So that is the angle that includes A plus B, angle A plus B. So now let's go back to there. So now we are going to employ this acronym where you have the SOHCAHTOA. The SOHCAHTOA acronym. So the SOHCAHTOA means that sine is equal to opposite all over hypotenuse. So now the opposite of the angle, the opposite of this angle A plus B is JF. The opposite is what? JF. So So we have JF, which is the opposite, all over the hypothesis. The hypothesis of that angle is CF. So CF. So look at CF. So now, having done this, we also know, look at it. Let's look at it critically also again. We know that JF is the same thing as JK plus KF. So look at it again now. JF is equal to JK plus KF. So let's write it. So this is equal to JK plus KF all over CF. So now we now need to divide. We now need to divide each of these terms with the denominator. So you have JK all over CF plus KF all over CF. So what we just applied here is the rules, the fraction rule, where you have, if you have A all over B plus C all over B, it's the same thing as saying you add the numerators. Since the bases are the denominators are the same, you add the numerators A plus C all over B. So is this expression we just used here now, which is this. Now if you look critically again, if you look, the KJ does not have any relationship with any triangle. Now, and we want to express that sine A plus B in terms of sine A and sine B. Now, we now have to look critically and look at this JK, the length, the equal length that relates with these two angles, because we want to express sine A plus B into the sine and cosine of A and B. So now when you look at KJ is equal to IG, and this IG relates is on the triangle that houses the angle A. So that means we are going to, now since KJ is equal to GI, so we now have to change that to that JK. Now I need to change the JK to GI all over CF plus KF all over CF. Now let's write sine A plus B will now be equal to, now if you look at it critically again, we have this. Now, and we also have we have KF. KF is working on this triangle. KF is on this triangle, and this triangle houses A. It houses what? Sorry, this length houses triangle A, angle A. This length is on this triangle that houses angle A. So this side is okay. And then now, since JK does not house any angle, sorry, and is not on any triangle, so what we're going to do is we'll move it to this place. Since it's equal to this, so we now, since this is equal to IJ, we'll now look at it, bring it here. Then now, having done that, there is a line. There is a line that is common to angle A and angle B, which is CB. So we're going to use that CG. We're going to use that CG to re-express this value. So now we have GI. So we can say GI divided by CG see, times CG divided by this CF. Now if you look very critically, you see that this CGI all over CF is the same thing as this, because if you cancel out this CG, sorry, if you cancel out this CG, you are left with GI all over CF. This over this is just the same thing as 1. It's just like the same thing as using 1 to multiply this value. So we're also going to do the same to this one, KF. Now, when you look at KF and CF, now the KF and CF has a common line. It has this line. This line, which is FG, houses this angle. Is on this triangle that houses angle B, and it's also on this triangle that houses angle A. So this line is common to this triangle, and it's also common to this triangle, just as this CG is common to this triangle that has GI, and also common to this triangle that houses CF. You see, so it's the same applicable to this KF. FG is common to it because it is part of the line that forms this triangle here, this triangle FGI, and is also part of this triangle FGC that houses angle B, and this one houses angle A. So now we're going to work with this common line, just as we work with the common line for C, which is CG. Now we're going to work with this common line, which is FG. So FG will now say KF divided by FG times FG divided by CF. So now you can cancel out this and it will still remain KF all over CF. So with this, now when you look at this, you have GI all over CG. Let's look at this thing again. GI all over CG. So now when you look, this GI is opposite of this angle. So it's opposite to this angle divided by the hypothesis. So opposite divided by hypothesis is, according to SOHCAHTOA, opposite all over hypothesis, that is opposite to angle A all over the hypothesis, is sine. So now it will now be sine. The angle it is opposite to is A, angle A. So now times, you have CG, CG all over CF, CG all over CF, CG all over CF. So CG is adjacent to angle B. It's adjacent to angle B all over CF, which is the hypothesis of the triangle. So now you now have cos, because cos is adjacent all over hypothesis. So you have cos B. So plus, so is applicable here. Now you have KF all over G. So KF is adjacent to A. So that will be cos A. So let's look at the other one. That one is what? FG all over CF. FG. FG is opposite to angle B. So all over CF, which is hypothesis, so is sine B. So you see, we have gotten this to be A plus B, sine A plus B equal to sine A plus B equal to sine A times cos B plus cos A times sine B. So, but if you have sine A minus B is the same thing as saying you say sine A cos minus B plus cos A sine minus B. So this, this expression is just the same thing as saying A plus minus B. A plus minus B. So you are just using minus B to replace all these values. Now, if you look at the now at the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now, if you look at it critically, now let's begin. Now, minus B is at the fourth quadrant, which is minus means you're moving clockwise. Now, let's say this is B. This is minus B. Now, although before I make a proof, C, which is cosine, is positive on the quadrant. All of them is positive here. Sine is positive here, and tangent is positive here. Only tangent is positive, only cos is positive here. Only all of them is positive here. Sine is positive, only sine is positive at the quadrant 2, at the second quadrant. The third quadrant is only tan theta that is quadrant that is positive. So now, but let's prove it now. You have B, which is negative. Now, sine here now is a negative, let's say it's a negative x. Here, sorry, negative y, sorry. Here is negative y, moving down y, negative. Then here is positive x. Now, sine is opposite. Now, here is positive. It's just positive. Let's say length. Or let's say x square plus y square all divided by, or that is the square root of x square plus y square. So now the cosine, the cos b, in this case cos minus b, let me put it like that, cos minus b will now be, cos is adjacent, the adjacent is x, the adjacent to this angle, which is x, divided by the hypothesis, which is the square root of x square plus y square. Now, but for sine minus b, you have the opposite, which is minus y all over the hypothesis. So you see, from this expression, minus y, so it means that sine is minus. So this would now be, this cos b, this, so it now means that cos minus b is equal to cos b, while sine minus b is equal to minus sine b. So we are going to apply that rule here now. If you add them, if you put them into this expression, you have sine A cos B minus, there will be minus here now, minus cos A sine B. So we have proved that to be sine A minus B is equal to sine A cos B minus sine B cos A. So okay, let me just write it well. Sine A cos B minus cos A sine B. So we have proved this. Now, if you also look at the diagram, now you see CJ is adjacent to this angle AB. So using this SOHCAHTOA, you have cos A plus B equal to CJ all over what? CF all over CF. Now, we needed to express cos A plus B in terms of angle A and angle B. Now, if you look now, angle CJ is not on any triangle. Is not on the single triangles. So the sides that are on the single triangle, on the single angle, not single triangle, on the single angles are CI and JI. So CI is on this angle A, JI is on angle A here. Look at it. So we are going to express CJ in terms of CI and JI. So for us to do that, CJ is the same thing as CI minus JI. Look at it. CI minus JI will give you CJ. Let's write it here. Look at it very well. CJ plus JI is equal to CI. So if you're looking for CJ, if you move this value to this side, it becomes minus. So it will now become CI minus JI. So that is what we got here. CI minus JI divided by CF. So we now have to divide each and every one of these with CF. So we have CI divided by CF minus JI divided by CF. Now, if you look at the triangle again, JI is the same thing as KG, because now this line is parallel to this line, and this line is parallel to this line. So that means KJ is equal to GI. So, and also KG is equal to JI. So that means we are going to replace JI with KG, because JI is not on any triangle. Is only on this trapezium. So, but the one that is on the triangle that houses the angle A is KJ, which is equal to JI. So we're going to replace JI with KG. So we replace this with KG. So we have CI all over CF minus KG all over CF. So that is it. Now you now have cos A plus B equal to CI all over CF minus KG all over CF. Now you have CI all over CI all over CF. You have CI all over CF. So now the one that is common to this triangle, these two triangles, is CG. CG. So we're going to now use CG to simplify that triangle to now use, because if you look at this triangle now, this CI and CF, both of them are on two different triangles. They are on this triangle and on this triangle. And the line that is common to those two triangles is CG. So we will use CG in order to relate the two lines. So the CG is common to the two triangles when you look at it. So CJ, that is what we're going to use. So in order to relate this thing, so we say CI divided by CJ times CJ divided by CF. So this divide this, okay, this is CJ. CG, not CJ, CG. Now if you cancel out this, it will still remain as this. Now you have minus. Now let's look at this other one. We have KG and CF. KG, we look at the line that is common to those two triangles. KG and CF. So KG and CF, the line that is common to these two triangles is FG. So we're going to use that FG. So we say KG divided by FG times FG divided by CF. So FG is common to those two triangles. So that is why we're using FG. While for here, CG is common to the two triangles that houses this CI and CF. So now let's look at this. CI divided by CG. CI divided by CG. So now you have CI adjacent to angle A, and the CI is adjacent to angle A divided by the hypothesis. So that should be cos A. So this is cos A. Now the next one, you have CG divided by CF. So CG divided by CF. CG is adjacent to angle B divided by the hypothesis of that triangle. So you have cos B minus. Now the next thing is the next one. Let me see. You have KG all over FG, KG all over FG, KG all over KG all over FG. So KG is opposite to angle A divided by the hypothesis. So you have sine according to this SOHCAHTOA, where you have sine is equal to opposite all over hypothesis. So that this expression KG is opposite to angle A divided by the hypothesis. So opposite all over hypothesis, which is sine A. So now let's look at the other one. The other one is FG all over CF. FG all over CF. FG all over CF. So now FG is opposite to angle B, is opposite all over the hypothesis of the triangle, which is opposite. So opposite is still sine using SOHCAHTOA, opposite all over hypothesis. So using the same SOHCAHTOA. Let me write it here again. SOHCAHTOA. So now we have gotten cos A plus B is equal to this. Now, if we now look for cos A minus B, cos A minus B is just the same thing as saying cos A cos minus B. This is minus B here. Minus sine A sine minus B. So you put minus here, you put minus here. So now, we have proved that from here, we have proved that sine minus B is equal to minus sine B, and cos minus B is equal to cos B. So is there any need to prove it? I don't think so. But let me still explain. You have minus clockwise. So you have, this is B, angle B. Moving clockwise is angle B. Now here you have minus y. Here you have x. So sine minus B will give you, now you have, here is minus y, here is minus, which is opposite all over the hypothesis. Let me say the hypothesis is L, all over L. So this will give you minus. Now let's say you now have, and let's say this side now is B2, and you have the same y here. So that means you have minus, now if you have sine, this is B here, sine B in the positive side, which is in the counterclockwise, you have sine B will be equal to y all over L, which is sine B. So here is meaning this is equal to minus sine B. Now for cos, we have cos minus B is equal to the adjacent, which is the x axis, the x divided by the length. So, and the same thing is applicable to cos B, which is x all over L. So that means cos minus B is equal to cos B. So, but if you want to memorize it, you can say cos is positive, only cos is positive here, all of them is positive here. Sine is positive at this second quadrant. At the first quadrant, all of them is positive. Tan is positive at the third quadrant. So that is the logic you can use to remember it. Now, well, with this logic, we can go straight away to tell you that since cos is, and here is minus, so you have cos minus B to be equal to cos B, and sine minus B is equal to minus sine B, to just be minus. So from here, but I just want to make it, I want to prove it, so that, let me erase this so that I will use that space. So I'll use this space to fit in the other thing. So from our understanding now, it shows that we have cos A is the same thing as cos B. Cos minus B is the same thing as cos B. So minus sine A, this sine B is minus sine B. So you have cos A cos B, minus times minus will be plus sine A sine b. So now this is it. So we have proved all. So this is all the addition formula. This is all. That is it. So this is all the addition formula, which is this too. So thank you for watching. Please subscribe, like, and comment on this video. Thank you. Have a nice day. And also share the video, please.